appreciate your attendance. I'm here to introduce Cory Isaacson, who is CEO and maybe more important, CTO, CodeFutures. After this event this afternoon, he's going to be signing original documents, drawings, conceptions that he's done at his booth. They're at booth 424, so please write that down. Look for it, 424. You can meet him and he'll be signing these. Right now, he's going to talk about big data. We've been talking a lot about cloud and Internet of Things here, but let's talk about big data, agile big data, dynamic big data, real-time big data, really big data. Cory, he has a couple of guests, one from Google and one from Strongview, I believe. Cory, take it away.
Can you hear me all right? There we go. So my name's Cory Isaacson. As Roger said, I'm the CEO and CTO of CodeFutures. I'm going to give you just a little bit of background today on what we're calling agile big data. So how many of you are worried about the size of big data and the growth of big data that's coming down the pipe? Okay, I hope some of you, because that's what we're going to talk about. If not, anyway, might need to go to another session. So basically, it's really become a big problem. And one thing that we actually know for sure is that anything to do with big databases is anything but agile. It's incredibly inflexible. It's a real big pain in the neck to manage. And we really want to talk about some real solutions and how we address these problems. Just to give you a little bit of background on our company, CodeFutures was founded in 2007. We were one of the early innovators in scalable big data systems. We were actually one of the first companies to enter this space before any of this was popular. And so we have a very long history of making leading technology. And basically, we have also my partner in the company is Andy Grove. He helped me found the company. We have the most famous VP of engineering in the world. Unfortunately, it's not that Andy Grover. We wouldn't have needed capital, but anyway. So anyway, our current technology is very, very good. It's been in production for over 4 years. That's our DB Shards product. And some of you may have heard of that. It's basically a database scalability tool. And we have a number of customers running it. It's been very, very successful. But what we found, even with our own technology, is we still weren't happy with the level of things and how easy it was to interact with. And so we're going to be talking to you about some new things today as well. We also are the sponsors of MapDB, which is an open source project. MapDB is a very, very high performance Java data engine. And for any of you who want to check that out, it's Apache licensed and you can download it and play with it. If you're a Java developer, it's quite interesting. But we use it a lot internally in our technology. So one of the other things, though, that we're really, really good at is T-shirts at Cloud Expo. And we have always had the leading and best T-shirts. We know how popular they are because we know how quickly they go. And this was obviously for DB Shards. And anyway, we've had this T-shirt for many, many years. We've been doing this at Cloud Expo maybe for 4 or 5 years, and we've used the same T-shirt. And we really were getting into a problem because we said, you know, we can't go back again with the same T-shirt. That's just not going to work. We can't do it that many times in a row. So we said, well, what are we going to do about this? And we put all of our best talent in the company on this problem. And we said, how are we going to solve this so we can make an actual better T-shirt? And what we came up with was, well, we actually need a new product. So I'm going to be announcing a brand new product that we're introducing today. I'm going to talk to you about it in a few minutes, and then I'll show you what the new T-shirt looks like too. So, all right. So we also have some help today at the show. We're working very closely with OpenCrowd. OpenCrowd is a system integrator here in the New York area. They work with financial services companies. They do some fantastic work. They have a booth also if you want to check them out. They really have done some really, really neat things. And we also have Google Cloud Platform helping us today. So Andrew Cowell is here, and he's going to be helping with the presentation. So he's going to be talking to you about the Google Cloud Platform and the partnership that we formed with Google, which we're very, very excited about to tell you. And in addition to that, we have Jeremy Stearns. He's the Chief Technology Officer of Strongview, and he's one of our early customers for the new technology we're going to announce. And so he's going to tell you from his perspective what he's been able to do with it, and I think it's very, very exciting. So rather than just hear from me, we're going to get a little bit of background from some help. But let me give you the background of why we decided to do this. Who likes an agile development process? right? Anybody like it when it takes a real long time to develop software and it's really complicated and has lots of bugs and it's really hard? Any fans for that? No. Well, I have one. Anyway, he works for me, but that's all right. So basically, the thing that we know is, why do we want agile software? And why do we want agile processes? Because we want to make our companies and organizations be able to respond quickly to market pressure. If we can't do that, we're going to be behind. And with big data, this is more important than ever. And the thing that we know is, you can have lots of agile processes, you can have very, very good developers and very good development methodologies, but if your database can't move, and it's really a static infrastructure, you're not going to get there. And so your database typically is the thing that lags an agile process. And that's what we're going to talk about, is how can we really get around that. So we really have looked at this problem. I've been working with databases my entire career. I've been on the consulting and application development side. I've been on the operations side. I've been on the technology side. And what I know is that I'm really not happy with how applications and databases interact. It's really too hard. It's too much work. It's too difficult to get databases to respond. And now when you're talking about big data, it's really hard. And so we wanted to see if we could address that problem. So we took a step back and we said, you know, maybe we're just looking at databases the wrong way. Now that's, I know, a pretty broad statement, but I've been doing this for a very long time, and it was a little bit embarrassing to say, well, maybe there's actually something wrong with how we approach the problem. And if we could approach it in a different way, maybe we could actually solve it. And so we actually did spend a lot of work over the past few years on this problem in our organization. And what we found was an application goes through a pretty common cycle. What happens is you start out with an application, and you have a simple schema in your database. And what do? You write some data, and you read some data, and you write some data, and you read some data, and it all works fine for about a week or two. Until what happens? Either the data starts growing really fast if you're successful, which is fun, right, but causes lots of problems, or you get a lot of new requirements and you have to meet those very, very quickly. And all of a sudden, your simple schema is not so simple anymore, and you have to get much more complicated. So then what can happen too is when you add scaling into the picture and your data gets so big that you have to actually scale, now you're putting in a huge scalable infrastructure, which can be great, but it greatly limits your choices on what you can do from the application side. Anybody here implemented a scalable database system? Okay, are any of you familiar with the idea that when you scale one way, it makes it difficult to do almost anything else? So it might support some use cases, but not others. We've seen that as a huge limitation. So what happens is, after this grows for a few months or a few years, what happens is you get a picture like this, where the application is going back and forth very, very quickly, doing all sorts of reading and writing and processing of the data, maybe writing the data back in different formats. You have really complicated schemas. We have one customer that has 500 different object classes in their schema that they have for their database, and honestly, they don't know what 400 of them are. They just have gotten lost. And so it gets very, very complicated. Then you have to write really complicated queries to try and get the data out that you want. And now if you add scaling on top of this, like I said, you can scale the application one way, and it's good for one single use case or a group of use cases, but it's really bad for everything else. And now it's incredibly inflexible, and it's really, really difficult to deal with. So this is the problem we're trying to address. What we've seen some people do to try and address it is they're actually going to newer database engines. So not just a different scaling structure, but they're actually going to a different kind of database altogether. So we were at a customer recently, and that customer actually has one application with 12 different database engines. They have probably every engine you've ever heard of. Some Postgres, some SQL Server, some Redis, MongoDB is in there. They have all kinds of different database engines. And what they did was they said, well, we really needed this one for this purpose, this one for this purpose, and this one for this purpose. Well, guess what it did is it made it so that the application now not only had to deal with the complicated database infrastructure, now it has to deal with several complicated database infrastructures. It's also very hard on the IT administration and everyone else in the organization too. And so to try and scale and to try and accommodate this, it's not a bad move to go to other alternative engines, but the problem is now we're really talking a very, very complicated picture that just can't move very fast. Add one more factor on top of this problem, which is that data is growing at an incredibly fast rate. We're all moving into the big data era now, and what we've seen is almost any organization we work with has some sort of big data problem, or they're going to start to have some sort of big data need to be able to respond to their marketplace. We're seeing everything from system data, mobile devices is creating a huge amount of growth. Now the Internet of Things, honestly, everything is going to end up with a CPU and a network connection in the next 5 to 10 years. Your car, your refrigerator, everything that you can think of, and it's going to generate hundreds of times more data than we have today. And we already have quite a bit. The numbers are pretty staggering. So the problem is, the bigger the data gets, the less flexible the infrastructure gets typically. So the problem just gets worse and worse and worse the further on you go. And the other thing we know is when you have data that's this big, there's no way you can actually get what you need from it on a historical basis. In other words, if you have 50 terabytes or a petabyte or whatever of data, and you want to get an answer from that data, you can't scan and read the whole thing, even if you have the best parallel infrastructure in the world. You're never going to be able to afford it. So we have to come up with a better way to do it. And what we've seen is this is driving a real need for real time. Because what do we want to do is we want to actually see what's happening from this data on a real-time basis as it's occurring. That's a very, very important principle, and it's a great way to solve the problem because now you can see what's happening while it's happening, and you don't have to worry about the last 10 years of it or even the last 6 months, depending on what your data volume is. So we really wanted to take this all into account because what we're worried about is if we don't do something, what's going to happen is we believe that we're going to end up with database repositories being static repositories for what I call dead data. So essentially what will happen is you'll end up with repositories that are very complex. Nobody knows how to use them. And one of the things I've seen, by the way, that's kind of interesting is you have an infrastructure like this. It's all set up. The people who build it get it to work somehow when it's very, very complicated. But sometimes they get another job. And that really leaves other people in the lurch, especially if someone new comes into a situation like this. It can be very, very difficult. So there's got to be a better way. There's got to be something we can do about this. And we said, again, maybe we've been just looking at the problem the wrong way. And we actually did some research on this and some testing, and we actually came up with some pretty remarkable answers of what we actually could do to just shift the way we look at the problem. Not so much totally new technology, even though we believe we have great new technology to solve the problem, but really looking at the problem in a different way. And what we found is if we actually look at data in an agile approach, a new view of data, and look at data as a stream instead of a static repository, we actually can get incredible amounts of information and we can make the whole environment incredibly flexible and incredibly fast. It's pretty brilliant what actually comes out of this. And what we mean by this is we can take existing applications, business applications, web applications, mobile, system data, data come from anywhere. We can turn it into a real-time stream from pretty much any database. And by doing that, we can actually start to ask questions of the stream and turn that stream into views of the data that actually mean something to our organization. And what's nice about this infrastructure is it's totally flexible, and using this approach, you can have as many views of the data as you want. So if one part of the application needs to look at the data one way and another needs to look at it the other way, there's no conflict. You can actually do both. And we want to have an infrastructure that's actually built for this. So it's basically a revolutionary way of looking at the problem. And by doing this, I can tell you that we've met with many, many early customers with our new technology, and we can solve problems so quickly for those customers now that before took us lots and lots of work to try and figure out. Now we can walk in and usually inside of one meeting or one presentation, we can actually say exactly how we're going to solve a given problem that they're addressing, and we can do it with their existing infrastructure. It doesn't take a whole new infrastructure or learn something completely new, which is really nice as well. So if we were going to put together kind of what the high points would be of an agile view for big data, these are the points we think are important. One is you want to be able to work with the data as a continuous, agile stream. You want to be able to see a stream of data in real time. You want it to be dynamic. You don't want it to be fixed in nature. It's very, very important. We want to be able to support agile views of the data as needed for application requirements. If any of you have done a lot of work on the application development side, you know what I'm talking about when you have to actually bend the application to work with the database. It's very painful, and application developers often spend a lot of their time doing that instead of building features that really mean something for the organization. So what we want to be able to do in this type of infrastructure is create views of the data that match exactly what the application needs so that it's really natural and quick for the application to get the information that it requires. We also want to maintain data integrity. This is very important. Right now, with these companies that are using multiple database engines, they're doing the data integrity themselves from the application layer, and I can tell you they're really not doing the data integrity management very well. It's very, very difficult to do. So we want to be able to do that within the same engine or across engines. That's very, very important as well. And we'd like to be able to isolate complex data structures from the application itself so that we can get back to that simple picture of a simple schema and a simple read and write infrastructure from the application. If we could do that, we're going to be able to move really, really fast, and we're going to have much better results. And lastly, it should be really, really fast. It should be totally scalable, and it should be completely hassle-free. You shouldn't have to worry about it. You shouldn't have to spend a lot of time managing it. It should be very, very automatic. So you probably figured out that we are working on something like this, and I am very pleased to make the first official announcement of our new technology, and we have our new T-shirt. So the product is called Agile Data, and we're going to be talking a lot more about it. What I'm going to do first, though, is I'm going to introduce my guest speakers, and they're going to help us present some information about this, and then I'll cover an actual example at the end. So first, we're going to start with Jeremy Stearns. He's the Chief Technology Officer of StrongView. And Jeremy, go ahead.
Great. Thanks, Cory. OK, so I'm going to say a little bit of background. I have just a few talking points, and we'll give it back to Andrew and so on. But I'm going to give you just a little bit of background about StrongView, what we do, the industry that we're in, and why we're so interested in working with technologies like what Cory has developed with Agile Data. So the baseline term for our current existence at StrongView these days is contextual marketing. It's an exciting time to be at StrongView and to be working with folks like CodeFutures because just like we see in events like this with a lot of innovation in the technology world around data and cloud and elasticity and data science and all these things, we have a similar level of innovation that's going on in the marketing world. So I feel very fortunate to be kind of at the intersection of a lot of interesting people, a lot of interesting ideas that are happening in both that vertical and that horizontal. And that's sort of, I've got content on both of those kind of concepts here today. So I mentioned contextual marketing. So let me give you a short kind of primer on StrongView. So we have a few hundred customers. They're typically Fortune 500 class customers or global, 500 or 1,000 class customers. They're the leaders in their industry, frequently retail, financial services, hospitality, et cetera. Some of the larger, more significant enterprises in those space use technology like ours. A simple use case to understand what they would use a platform like ours to do is you go into a retail store, you buy something at the checkout counter, they say, would you like to be on our mailing list? If you said, yes, I want to be on our mailing list, that email address goes to somebody in a marketing department in that retail company, and they use technology like StrongViews to design loyalty kind of ongoing engagement programs with each of those customers. Right? So you might then get an email from that brand that says, welcome to our loyalty program. Here's some information about products and services available to you. And then that begins a relationship that goes on for some period of time, hopefully, where each side gets to know each other a little bit more. And as that person interacts with that brand in different ways on different channels, all that data is accumulated, and that creates context, or that creates data available to be interpreted as context. To be used by that brand to build a relationship with that person. This is not spam, by the way. This is opt-in. There's always the can spam compliance stuff where you can opt out. So this is about positive relationship development, and we have a lot of brands that do that across millions and tens of millions of users per brand. So a lot of this comes back to context, right? And context from a tech standpoint goes back to, in a sense, the 3 V's of big data, right? And we see all of those at StrongView. there's the volume, the variety, the velocity. All that ties into how can you bring contextual data to bear on making new marketing decisions, new communication decisions with each member of your audience, each segment of your audience, to show that you understand where they are and what are the things that they value about that brand. Okay, so it means understanding and complementing what you understand the customer's habits to be and where they are in the journey of the relationship with your brand. And that implies, for folks like us, new technology. So how do we actually make that happen in a way that's innovative? And that is where we use innovative ideas and technologies like we're all seeing here this week and we're talking about here with CodeFutures. At StrongView, we call all of this present tense marketing. If you want to read more about present tense marketing, there is a website called presenttensemarketing.com that may or may not point you back to StrongView, where you can read a lot of things about what that means. Okay. In more concrete terms, right, contextual, when you talk about marketing, marketing platforms and building contextual relationships with your audience, there's all these different layers of things that feed into that, to a fully informed contextual understanding of the segments of your audience and the members of those segments of your audience. So you've got location data, right? Where is that person physically, and where have they been historically, insofar as they've had an ongoing relationship with you? What are the devices, obviously, that they're receiving your messages on, and that they're replying to you on? And what are the activities that all their historical journey and interactions imply that they may be doing either explicitly or implicitly? And then outside of the things that you directly gather that you can directly gather from that kind of relationship building with your audience, there are things outside of that audience that are environmental that may also influence a full understanding of context. So it may be weather data. Weather may influence whether people go into stores to shop or whether they do it more online, for example. Financial conditions may influence people's behaviors. So there's that environmental aspect to context as well. Okay, and the key thing is, how do you actually interpret all that in a way that we can actually act on? Okay, so briefly, this is a very high-level view of what our technology is, right? And so you've got there in the upper left campaigns and programs. That's sort of the brain, having absorbed all the insight that's available. How do you actually make decisions about the next kind of marketing messages that you want to send to members of your audience? After you make those decisions, then there's a content assembly process. There's all this personalization that goes into actually composing the message that actually has your name in it. It has the particular products in it that you're interested in. And then actually sending those messages out on those different channels to those different audience members, and then tracking the results that you get from having delivered those or attempt to deliver those. Okay, as that data comes back, then we have this event routing problem, which gets into what we're going to talk about. Event routing is going to collect all that feedback that comes back from the outside world, and then feed that into analytics and feed that back into new insights that would inform new program designs and new campaign behaviors. Okay. In terms of the 3 V's, the first aspect that we tackled at StrongView is in that bottom area around pure analytics, pure big data scale, big data volume, right? So in that area, we rolled out a product last year based on Amazon Redshift. It's an elastic data warehouse that deals with all of the scale aspects of collecting all this data. We collect tens of billions of new events per month across our customer base. All that feeds into now Redshift clusters that's scaled elastically, and we feel good about the tools we built on top of that to deal with the volume and the variety aspects of the big data. What we hadn't been able to solve with Redshift is the velocity aspect. It's really not a fit. Like Cory mentioned, every technology is suited for some things and not suited for other things. Redshift is good for the volume side. It's not so good with the velocity side, right? Sort of bulk loads and aggregate analysis. So we went back with Cory and his team over the last year and looked at this event routing problem and thinking about how do we tie that all that data back in more real time so that we can make more real time more real time reaction to the new data that we're seeing. And this is a high level view of what that solution framework looks like. So Message Studio on the top left is our code name for our core campaign management and program design product. So that's generating all these messages and it's collecting all that data. and then now that's streaming data into the streaming data core that we're operating with on this Agile data platform. It's also collecting data from third-party sources, but all that in real time, right, with a couple of seconds latency as opposed to a few hours latency. And by the way, in the marketing world, a lot of folks consider a few hours latency pretty real time. But we want to continue to innovate, and we feel like there are real opportunities to do that in a few seconds latency. Sorry, I'm going a little long, so let me accelerate. Through that real-time streaming data core, we're then rolling that data up into real-time views that allows us to see what's really happening in real time, and we take follow-up actions. A quick scenario there is you check into a hotel, and we're in principle getting that feed of data that for those hotel check-in events. Through that streaming data core, we're looking for patterns, right? And we see, again, this is opt-in data, so don't get spooked. But if you have the relationship with these brands and you're okay with having this happen, we get that event. We pattern match it. So we see what is the pattern, what is the interaction pattern this person has had with this brand, with this hotel brand, for example, over email, over mobile, over website interactions, et cetera. And what do we know about that person otherwise? And if that matches a pattern, then in real time text that person a coupon for a drink at the bar, right? So that's not just about intelligence, it's about intelligence in real time. If you process that, the next day, it's too late. So this is with a few seconds latency. So this is a key thing we're rolling out at Strongview later this year in our own beta program, and we feel like we've made a lot of progress on it with Cory and his team. So that's that. If you have any questions about it, we'll take questions, time permitting, at the end.
Great.
Cory.
Thank you, Jeremy. So anyway, that gives you a very good use case of the way Agile data is being applied. Strongview worked very closely with us to help us formulate the product and look at all the different things that we wanted to support. And they're doing some incredibly innovative things with the technology. We're very excited about it. So what I want to do now is I want to introduce Andrew Cowell. He's the product manager for Google BigQuery. We have formed a great partnership with Google Cloud, and we're very, very excited about the potential for Google Cloud and what we can do with this technology. And he's going to tell you a little bit about that, and then I'll show you an actual example of what we're doing together, and we'll take it from there.
Great. Thank you. I just wanted to spend a couple of minutes giving you a little bit of a flavor of the platform that helps to support the work that Cory and his team have done in putting Agile data together. So I'm a product manager on a platform, the Google Cloud platform at Google. And this platform is built on the same infrastructure and in the same data centers as all the rest of the Google services. And so I really just wanted to give you a sense of, well, what does this kind of infrastructure look like? Here, for example, is a 110,000 square foot facility in Council Bluffs, Iowa. And it allows you to do, obviously, very efficient storage, very efficient compute, but also very efficient analysis with BigQuery that we'll talk about in a second. What kind of scale are we talking about when we look at the Google infrastructure? For example, this infrastructure handles 1.5 million new devices activated every day, 6 billion hours watched on YouTube every month. Nobody recorded that, did they? Watched every month. And 20 billion pages crawled every day for indexing and search for Google search. And to support this scale, this infrastructure is global. We've created a network of these data centers for performance and for redundancy around the world. Another example of one of these is in Oregon. So this is actually the cooling facility for our data center up in Oregon, and all the different pipes there are colored based on different functions that they happen to have. In the last few years, we actually built a new data center in Finland out of an old mill that's beside the Baltic Sea, and we actually use Baltic seawater to cool the data center to be more green. This is an example of our data center in Atlanta. The green and blue high-efficiency LEDs are there to indicate that all is well. If anything actually does go awry and someone is dispatched out to take a look at it, the offending unit will actually be blinking red or so on, so that they can easily address the problem. And here actually is another one in Oklahoma, color-coded wiring, so very consistent and very easy to manage. by the people that we have on site, something that people don't need to worry about if they're building applications on top of this infrastructure. So you or I may never see and never be inside one of these data centers, but your code, your data, and your queries can be and can work on this data center and the other data centers that Google operates. And to do this, Google has a suite of products as part of our Google Cloud platform that allow you to do this type of processing, compute, storage, and analysis. We have a number of big data solutions that are part of the Google Cloud platform. The one that I'm responsible for is a product known as BigQuery. BigQuery is an application that allows you to take advantage of this distributed infrastructure to do parallel processing, so that you can do queries across terabytes of data in seconds, that you can do this interactively, you can do this using common tools such as SQL, that you can do this without the headaches, and open interfaces and APIs, and you can do this without the headaches of provisioning or the headaches of administration. And this is the component that we're proud to say helps to power the product that Cory and his team have put together in Agile Data. Pass it back to you.
Great, thank you, Andrew. So for any of you, by the way, who haven't looked at Google's cloud offering, it really is very, very impressive. We continue to be more impressed all the time, the more we learn about it. And so that's really why we partnered with them for our first implementations of Agile. So Agile Data, by the way, will run in any data center or any environment, but we are going to be partnering more closely with Google to make some things there very, very easy. And I want to give you an example of this, particularly integrating with BigQuery, because we think it's such a fabulous technology. You know, everybody in our business likes to say that they do things the same way that Google does. If you look at any scalable database technology, they'll say we're using the same kind of techniques that Google does. We finally figured out it would be better to actually use Google technology instead of say we're doing it like Google. So that's what we're actually doing, is incorporating some of their technology into Agile Data and making it exposed. So this is an actual stream flow that we actually put together with Agile Data. We'll have a demo of this, by the way, later this afternoon, so you can actually see it run. But the concepts are very simple with Agile Data. What we do is we take any existing data source. In this case, it's a MySQL database. We turn it into a stream. That's what the S's are. The streams are basically nodes that can actually manipulate the data into any form that we want and reliably stream them to the next component in the flow. And the V's are for views, and those are the Agile views that I talked about earlier and the need for doing that. So we basically can essentially morph something in a stream. We can put it into a view if we want to, if we need to. Once we put it into a view, it's durable and it's queryable from that particular facility. And that facility could be within Agile Data, so some of the views are right in Agile Data itself, and other ones are running in something like BigQuery. So we can actually use BigQuery in this case as an Agile Data view, which is a really, really neat concept. We can extend this to pretty much any database engine that we want to. So it's all very, very fast. In this particular flow, we had a pretty interesting use case. Is basically we said, let's take a simple MySQL order entry system. So we have order header, we have order lines, and let's say it's a shopping cart type application. We're getting very, very high volume, and what we want to do is we want to only process orders that have been shipped. We don't care about an order while it's being built or it's in a shopping cart. We just want to know when it's being shipped. Why? Because it's not going to change anymore after that. So we wanted to just look at the data once an order is actually shipped. And that's also when revenue is generated for most organizations as well. So basically what we did is we turned MySQL into a stream using the MySQL transaction log directly. And so we can basically detect all of the orders that are set to a shipped status. And as soon as they are, we actually can take those orders and pull them out of MySQL. We get the order information, the order line information, no matter where that MySQL database is, and we can reliably stream it to the Google Cloud infrastructure. And when it gets there, we do two things with it. One is we pump it right into BigQuery so that we can do any type of analytic query we want on terabytes of data, or even more than that, honestly. You can get very, very large there. But the other thing we're doing is we're using Agile Data itself to actually aggregate the data real time so that we can see a real-time flow and a real-time stream of the data on a summarized basis. So you'll see a lot of applications that need real-time dashboards or need real-time capabilities or management reports or any of those kinds of things. Why not do that summarization up front when you know what it is that you want? So we basically have two kinds of use cases here. One is we're basically pre-summarizing data for use cases that we know we have that are very, very common, so we can get that data incredibly fast, hundreds of times faster, by the way, than if you tried to do it crawling the original data source. And then we have BigQuery for doing other ad hoc queries where we really are doing more data analysis and we're not really quite sure what we're looking for. And there we can scan, again, terabytes of data in seconds and put it together. This entire flow, like I said, we'll show you a demo of it later. I think it's around 2 o'clock at the demo theater where you can actually see it running. Just takes a few seconds. But the important point about this is we want you to be able to do this in a few minutes. This shouldn't take a lot of time to do. You shouldn't have to change your existing application. You should be able to start from what you have, be able to integrate it with something like this, and put it into basically the data forms that you actually need so that you have these agile views and you can start working with it right away. So anyway, I hope you find it interesting. You can ask us more questions at our booth. You can come and see the demo later today, and we'll be available to talk about it then. So in summary, we are announcing today the opening of the private beta for Agile Data. I will tell you that we're looking for interesting use cases that we think will be a good fit for what our technology will do. If you're interested in working closely with us in trying something new, we think you'll find it very, very interesting and hopefully very meaningful to your organizations. We have several customers. They're going to be going forward in this category as well, and we're very, very excited about that. You can find more about the product on our website, and also, as you heard earlier from Roger, is that I have a new book coming out, and if you're interested in that, you can find out more about it. This print that he was showing you is actually from the book, and so because it's an ebook, our publisher said, we want you to do a book signing, and I said, well, how am I going to do that? So we decided that I could hand sign numbered prints, so they're actual numbered prints from diagrams in the book. So anyway, it's a lot of fun. All right, so we have a few minutes left for questions. We can't take too many here, but we'll also be around afterwards and again at our booth later today. So any questions from anyone? Okay. All right, well, thank you very much for your time.